Today's lesson is finding rational zeros. In order for us to try to understand what a rational zero is, we need to understand the theorem. The theorem tells us that when we have an equation that says x squared plus 3x minus 1, the theorem says that our constant number, which is the number that doesn't have a variable, that number, the constant, which is my -1, is going to be divided by the leading coefficient. And again, x squared means 1x squared. So I'm going to say leading coefficient, which is also 1. All right, so your possible rational zero for this equation would be a positive or negative 1. And that is the rational zero theorem. Again, it is the factors of your constant number, which is the number that is all by itself, divided by the leading coefficient, which is the number that is attached to your highest exponent. And every time it'll be a possibility of it being a positive number or a negative number. Now, using the rational zeros theorem, we need to look at our constant, which is our 8, and we need to find the factors of that. So the factors of 8 are, we have 1 times 8, and 2 times 4. Then we look, again, we have to have division. The factors of our leading coefficient, and again, this would be a 1. So the factors of 1, they are 1 times 1. From here, we have to remember that we're going to say, okay, it's a positive and a negative. So I'm going to say, right here, we have a positive or negative 1 over 1, a positive or negative 8 over 1, a positive or negative 2 over 1, and a positive or negative 4 over 1. Now, you might wonder why I am stressing the over 1, and it's simply because that a lot of times people will forget that there's supposed to be a denominator for this theorem. But when they're all 1s, you can go ahead and rewrite that as a positive or negative 1, positive or negative 8, positive or negative 2, and a positive or negative 4. What we have to do now is to decide which one of those to use in synthetic division. So I'm going to go ahead, because this is my equation, I'm going to write it in the synthetic form. I have 1, -7, 14, and -8, because I have 3, 2, 1, nothing for exponents. So I did not have any missing. Now, what I'm going to do is I'm going to look, and I'm just going to choose one of my possible rational zeros. And I think I want to choose 4. So I'm going to try a 4. And we'll see if it works. Unfortunately, with this, you will have an instance where you might choose the wrong number. And so if it doesn't equal 0, then that means you'll come up and you'll choose another possible rational and solve again. But we're going to hope that 4 gets us what we want, which is a 0 right here. The first thing with synthetic, we bring down our first term, the first coefficient. We multiply outside. 4 times 1 is 4. We add inside. A -7 plus 4 is a -3. We multiply outside. 4 times a -3 gives us a -12. We add inside. Positive 14 minus 12 is 2. And then 4 times 2, adding outside, is 8. And so a -8 plus 8 is 0. So because this is 0, then 4 is a 0. Now, we have to find all the real zeros. And so what we're going to do now is I'm going to go ahead and make another synthetic box. And we're going to choose another one of these numbers to see which one can get us to 0 again. This time I want to choose, let's try 2. We're going to bring down the first number, which is 1. Multiply outside. 2 times 1 is 2. Add inside. A -3 plus 2 is a -1. Multiply outside. 2 times a -1 gives us a -2. You add inside. 2 minus a -2 minus 2 is 0. So again, my remainder is 0. So 2 is a 0. Now, I still have 2 numbers here, so that means I have one more possible 0. And so I'm going to go and try one more synthetic, and I want it to equal the -1, or to cancel out -1, after I drop down, bring my first one down, which is 1. So what times 1 can cancel out a -1? I would think it would be 1. And so I'm going to try 1. 1 times 1 gives me 1. So a -1 minus plus 1 gives me 0. So again, my 1 is a 0. Now, if we want to put that in factored form, because there will be times that you need it in factored form, just like we did on our previous lesson, you will make this, because this is saying x equals 4. And so if x equals 4 and we want to make it a factor, we're going to bring the 4 over to the side with the x, and that means that we're going to change the sign. And so we now have x minus 4 as a factor. You can do that again with your 2. X equals 2. You bring over the 2. We have to change the operation. And so now we have x minus 2. We have the first, x equals 1. And so again, we're going to bring over the 1 to the side with the x and change the operation, so we have x minus 1. So now not only have you found all the zeros, you have also listed the factors. What we have to do, we have to think back to the rational zeros theorem, and remember that means the factors of the constant, which are 1 times 4, and then 2 times 2, are over the factors of the leading coefficient, which is 2 times 1. Now, what a lot of people forget when they are trying to list the possible rational zeros is that when you have more than one number on the bottom, you have to list every factor on top over every factor on bottom. And so what I'm going to do is I'm going to come over here and I'm going to say 1 over 2, positive or negative. Every time it's going to be a positive or negative. And then 1, positive or negative, 1 over 1. Now I can mark out my 1. I have to say, okay, well, 4 over 2, positive or negative, and a positive or negative 4 over 1. Now I've done my 4. Again, we have to say, since this is 2 times 2, you only have to list it once, but we have to say a positive or negative 2 over 2, and then finally a positive or negative 2 over 1. And that covers both of those since they're the exact same. I know that most people have a hard time looking at fractions. So what I'm going to do is I'm going to rewrite as much of this as I can as whole numbers. And so now I can say a positive or negative 1/2. And then 1 over 1 is a positive or negative 1. We have 4 divided by 2 is a positive or negative 2. 4 divided by 1 is a positive or negative 4. 2 divided by 2 is 1. We don't have to list it since we already have it. And then 2 divided by 1 we already have. So here are all the possible rational zeros of this equation. The next step is we're going to go ahead and put it in synthetic. And so again, we need highest exponent down to no exponent. So we have 2, 4, negative 2, negative 4. Now we have to decide which of the possible rational zeros we're going to use. And I think I'm going to use a negative 2. So remember, the first coefficient always comes down. We multiply outside, a negative 2 times 2 is a negative 4. We add inside, 4 minus 0 is 0. 4 minus a negative 4 is 0. We multiply outside, a negative 2 times 0 is 0. We add inside, a negative 2 plus 0 is negative 2. A negative 2 times a negative 2 is a positive 4, and a negative 4 plus 4 is 0. With our remainder being 0, we can say that a negative 2 is a 0. Again, we can go ahead and start our next synthetic box. And we can look to see what are the possibles. Again, it can't be higher than 2 over 2. And so we know that we're not going to use 4 again. All right, so we can choose between 1/2, 1, and 2. So I'm going to choose 1, and I'm going to make it a negative 1 because I can choose either one. So I'm going to choose a negative 1. We bring down our first coefficient. We multiply outside, negative 1 times 2 is a negative 2. 0 plus a negative 2 is a negative 2. A negative 1 times a negative 2 is going to give me 2. And a negative 2 plus 2 is 0. So again, because my remainder is 0, I can say that a negative 1 is a 0. And then the last one, again, because we want is one number being left. So we're going to use synthetic one more time. And what I do is I try to think, okay, well, I know this is going to be brought down, and I want this to cancel out. So I'm going to look at my possible rational zeros and see which one can be multiplied by 2 to get me a positive 2. And so I think, and I'm like, okay, well, this time, how about I use my positive 1? And so 1 times 2 gives me 2. A negative 2 plus 2 gives me 0. So 1 is a 0. again, if you want to put that back in factored form, you're going to solve x equals a negative 2. You're going to move the negative 2 over to the side of the equal sign that has the x. And in doing that, you change the operation. So it becomes x plus 2. So negative 1 means x equals a negative 1. We want everything to one side, and so we're going to move the negative 1 over to the side with the x. We change the operation, and it becomes x plus 1. And then our last one, our x was equal to 1. Again, we want everything to one side, and so we have to change the operation, and so we have x minus 1. So our zeros are a negative 2, negative 1, and 1. And then our factors are x plus 2, x plus 1, and x minus 1.